Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. In this session we will see that when we see some electronics board, we see different types of capacitors with different colors, with different sizes, with different package. These are non-polar capacitors, non-polarized capacitors. We can say AC capacitors. When we see a polarized capacitor, that is a DC capacitor, it has some voltage rating, some capacitance rating, and its manufacturer code, the series number, then temperature. It has polarity marking. So this is a polar capacitor. If we see some non-polarized capacitors, it will become in different markings. Sometime there is written 250 volts 104J 104K. What is the meaning of the last digit, that is J, K, B, C, D, E, and how we can determine the capacitance? Let's start. And I will suggest to watch this video full. If you will find this video informative for you, please like this video and share it with your friends, so that might be it will helpful for someone. When we see a capacitor, for example, it says some voltage rating 2A 474J 2A. This is the voltage rating. Then it have a capacitance rating, then it have tolerance. Okay, 2A, if we see this chart 2A, that means it is 100 volts. 2A, that means it is 100 volt. I will give the link of these charts in the video description. You can download it. If it is in code form, it is 2A, that means it is 100 volts. If it is 2Z, that means 180 volts. If it is 2D, 200 volts. You can follow these charts to decode the voltage. Then we have 474. That means 4, 7. We will write it as it is. Then we will put 4 zeros. 1, 2, 3, 4. This is in picofarad. If we want to convert in nano, so we will put dot here. So it is 470 nanofarad. We will divide it by 1000. It is 470 nano, or we can say it is 0.47 microfarad. So in this way we can identify what is the capacitance value. If it is 221, that means 2, 2 and 1 0, 220 picofarad. Capacitance, you can decode it in this format. If it is 471, that means 4, 7, and this is the multiplier, number of zeros. 1, that means 10, 470 picofarad. If it is 472, 47, then these 2 zeros. Very simple. It is called multiplier digit. So it is 4700 picofarad. If it is 473, it is 4730 picofarad. If it is 474, 4 zeros, 1, 2, 3, 4 picofarad. 475, 4, 7 and 5 zeros, 1, 2, 3, 4, 5. This is the capacitance. You can decode the capacitor value. What is code written on the body, you can decode it very easily. For example, if I see this, it is 400 volt 334J. It is 400 volt 334J. That means 3 3 4 zeros. 1, 2, 3, 4. Then J. So it is 33000 picofarad. We can say it is 330, then remove 3 zeros. We can say we will divide it by 1000. So it will nanofarad. 330 nanofarad. Then the word J. It is tolerance. This is the tolerance chart. We have different suffix that are A, B, C, D, E, F, G, H. If A is mentioned in the end, if it is 334A, that means plus minus 0.5 picofarad. So it is very special. So it is not commercially available. Then the digit B. It is plus minus 0.1 picofarad. It is also special. C. Plus minus 0.25. D. Plus minus 0.5. These four numbers are used in very special communication equipment and very precise where we need a special capacitance. At that time these numbers are used. Then here is E, that is 0.5%. It is also very special. It is 220E. So this capacitor is used in frequency generators, frequency synthesizers, signal generators. Why? When we use this capacitor, that means its frequency response will 100%. Because in generators, synthesizers, signal generators, frequency generators, this special capacitance is used to stabilize the frequency. Then there is F, plus minus 1%. It is 1000 picofarad plus minus 1%. Plus minus 1%, that means it is category F. So we will place it in category F. The same is here, 5F. 5 picofarad, 1%. Then G. It is plus minus 2%. F271G. So it is also a special capacitor for frequency generators, synthesizers. It is not commercially used. In F series, if the capacitor value is less than 10 picofarad, that at that time the tolerance will plus minus 2 picofarad. We can say if it is 8 picofarad, so 8 plus 2 picofarad, 8 minus 2 picofarad. So the capacitor value will 6 picofarad to 10 picofarad. At that time, if it is 8F, that means the capacitor value will from 6 to 10. Here it is 5F, that means 5 plus 2, 5 minus 2. 5 plus 2, it is 7 picofarad and 3 picofarad. If you test it with the capacitance meter, its value will within this range. If it is above 10 picofarad, at that time we will consider plus minus 1%. The same is here. If the capacitor value is less than 10 picofarad, at that time it is plus minus 2 picofarad. And above than this, it is 2%. Then J. J, K, L and M. These are commercial components. These are used widely in electronics. J, it is plus minus 5%. If we have 100 picofarad capacitor, plus minus 5%. So 100 minus 5 picofarad, it is 95, and 100 plus 5, 105. So the capacitor value for 100 picofarad with the digit J, it will 95 to 105 picofarad. Similarly here, if it is K, that means plus minus 10%. At that time, these capacitors will provide the capacitor value from 90 to 110 picofarad. Then L, it is plus minus 15%. It is not commonly used. The next digit, that is M. It is most commonly used in the electronics. So it is plus minus 20%. N, it is used in class X capacitors, it is plus minus 30%. X1, X2 capacitors, so it is plus minus 30%. Then the digit P. This is another very special category. So its capacitor can increase 100% double, but it will not decrease the capacitance. In some circuits we need these capacitors, so this is also very special. As we discussed before, H, this is special range and this is special range. So these are used in signal generators, frequency synthesizers, communication equipment. It is 0.01 P. So if the word P, that means plus 100% minus 0%. So its capacitance will not decrease, but it can increase up to 100%. If it is 0.001, so its capacitance can reach 0.002. 0.001 plus 100%, 0.001, 0.002 picofarad, but its capacitance will not decrease than this range. Then we have S. If S, that is plus 50% minus 20%. W plus 200% but minus 0%. X rating, that is plus 40% minus 20%. Then we have Z. These capacitors, these are plus 80% and minus 20%. So it is 105Z, it is 25 volt. So in this way we can decode what is the capacitor value. Let's see one capacitor here. For example, this is 473J, 100 volt. So that means 4, 7, 3 zeros, 1, 2, 3, and then the word J. It is picofarad, and then J. J is plus minus 5%. 4700 multiplied by 0.05%, it is 235. 470000 plus 235 picofarad or minus 235 picofarad. Its range will become 46765 picofarad plus, so 47235. So this capacitor 473J, if we test it with multimeter, at that time its capacitance will be between these two readings, 47000 picofarad plus 235. This reading, this is the upper limit, and if we deduct this value, so it is the lower limit. The exact value must be 47000, but if its reading is between this reading on the capacitance meter on some device which can measure the capacitance, at that time this capacitor will good. If it will go above or below, at that time that capacitor is not good. So friends, I hope so this video is informative. If it is informative, hit the like button. If you have any question, please let me know in the comment box. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.